All right, let's take a look at section 5.3. It's quite a bit different than the last two sections we did. Remember the last two sections, circumcenter, orthocenter, and all that kind of stuff? All right, this really is a lot different than what we did before. It's not hard. It's pretty easy stuff, actually. But we're going to deal with inequalities. Instead of things being equal to each other, we're going to have things that are not equal to each other. Okay, so if I have two things that are not equal to each other, if I was going to compare them, I would say that one thing would be what? Compared to the other thing, if they're not equal. One would be less than the other one, or it could be what? Greater than the other one. Yeah, exactly right. So that's what we're doing when we talk about inequalities. And so that's the first thing that they do here. They call it the comparison property. Let me get my writing all straightened out here. All right, the comparison property, I'm not going to spend a lot of time on it. I was even considering not even talking about it, but it's in my notes, so we might as well. Comparison property. And that's what we do a lot of times with inequalities. We compare something because we compare it to another thing. We say this is bigger than this or it's less than that. That's basically what we're doing. Even if it was equal, you're still comparing them, aren't you? Would you agree? Yeah, so here's basically what it says. It's kind of common sense, really. It's nothing like earth-shattering, but it's just written down so you can see it. So they start off with this. If A equals B plus C, and as long as C is positive or greater than 0, then, all right, so watch. If A is equal to B plus C, and if C was a positive number, all right, so it's not 0 and it's not negative, then tell me something about A and B. So if these two things add up to be A, what must be true about A compared to B? If these two add up to be A, then A's got to be what to B? It's got to be bigger. It's got to be greater than. And there's our greater than symbol. Remember that? Is that better? All right, so A is greater than B. Everybody see that? Because if you have two things, watch. 2 plus 3. What's that equal to? 5. 2 plus 3 is 6. 2 plus 3 is 5. I know, it's been 2 weeks off, so maybe a little slow on the math. Yes, ma'am. What's that? C is greater than 0. That C is greater than 0. All right, so watch this. I just thought of just two of the easiest numbers I could add up, okay, 2 and 3. All right, so compare this to this. This is always going to be what? Bigger than this. Would you agree? As long as C is not 0 and as long as C is not negative, right? If I add two numbers together, the sum of those numbers has to be bigger than either one of these numbers. Would you agree? So this has got to be bigger than B, or 2, and this also has to be bigger than 3, because if these two add up to this, what they add up to B has got to be the biggest. Agreed? Okay. Like I said, it's kind of like common sense. You know what I mean? It's just the fact that we're writing it down. All right? So there you go. All right. Now, what are we going to do with geometry? There's got to be some geometry involved, wouldn't you agree? And there is. So let's draw a triangle. It's a triangle that we've kind of seen before, but we're going to talk a little differently, a little more, we're going to talk differently about it, I guess. That's the way to say it. And we're going to call this ABC, A, B, C, and we'll call this angle 1, and that just keeps going like that. All right, so here's what we have. And they call it the exterior. I don't think I'm going to write down the whole theorem. It's probably in the book. I'll write this whole word. The exterior angle inequality. Now, we did something like this not all that long ago, but we talked about the equality. Okay, what's equal to it? Remember this? This is the exterior angle is equal to the sum of the, do you remember what the words are? The sum of the remote. Very good. the sum of the remote interior angles. Do you remember that? Yes? Okay, so watch this. So if angle 1 is equal to angle B plus angle C, and would you agree that that's true? Right? Yeah, because we said in another chapter that the exterior angle is equal to the sum of the interior angles. So that's true. So what does that mean about angle 1? That means angle 1 has to be greater than what? Than angle B, and angle 1 has to be what? Greater than angle C, right? Just like we did before. We were just dealing with regular numbers before, right? Just regular numbers. Now we're dealing with angles, but it still holds true. So here's what the theorem says. Again, I'm not going to write it down just because it's already in the book. If you want to write it down, you can. But I think we've kind of explained it already just with this picture. It says the measure of an exterior angle of a triangle. Which one is the exterior angle? Angle what? Angle 1. Good. Okay, so the measure of an exterior angle of a triangle is greater than the measure of either remote interior angles. Did that make sense to you? So this exterior angle has to be bigger than either one of these. So angle 1 has to be bigger than B, and angle 1 has to be bigger than C. And that's what we showed right here. And that's like that comparison property that we just talked about. Everybody with me on that? All right. Why does angle 1 have to be bigger than B and angle 1 has to be bigger than C? Well, because B and C add up to be angle 1. So the answer has got to be bigger than the two things that are added up to be the answer. You got it? Okay, enough of that. I don't know if I'm getting blank stares because this is so super easy that you're saying just keep going, or that you don't understand what I'm talking about, or that you're just trying to wake up from being off for 2 weeks from school. Maybe it's part C. All right, let's talk about this. They call this the greater angle theorem. And it kind of has to do a little bit with what we've been talking about. The greater angle theorem. Again, I'm not going to write out the whole thing, but I will draw it though. So let me draw, I'm going to draw a couple triangles. Oops, there we go. And then right there. Okay, so let's put some numbers in here. Let's say that's 100. Again, I don't know if this is drawn to scale. It's probably not. I just kind of drew it. If that's 100 degrees, this is 60 degrees, and this would be what? 20 degrees. Okay? I think we have talked about this part. If I have a triangle like this, tell me which one is the longest side. I'm going to go A, B. Well, there's no hypotenuse to this. Why is there no hypotenuse to this? There's no right angle, right? Okay, you can only have a hypotenuse when you have a right angle. But take a look at this. Which one, I think this is what I'm trying to do. Oh, you know what? I wrote down the wrong thing. I even put a note in red to use this other one. Forget that. We're going to get to that in a second. This is what we're actually learning today. Sorry. I'm looking at my notes and I just... we'll get to that. Don't worry about that. Okay, so we will get to that. So just, if you wrote it, no biggie. We're just going to do this one first. Okay, this is the one where the theorem really works. So what if I said that this was 13, this was 14, and this was 12? And this is angle L, M, and N. Okay? Now, here's what the greater angle theorem says. Let me read it to you, and then we'll talk about it. It says, if two sides of a triangle are not congruent, well, we have that, don't we? None of those sides are congruent. Would you agree? Okay, so it says, if at least two of the sides are not congruent, then the larger angle is opposite the larger side. Hear what I just said? the larger angle in here, if you wanted to pick out which one is the largest angle, it's going to be the one that's opposite the what? The largest side. So which one's the largest side? 14. So what's the angle that's opposite that 14? Angle M. So in order from largest, we'll go from large to small. Okay, L to S. It's supposed to be an arrow. All right, from largest to smallest. What's the largest angle? Angle M. So that has to be greater. What do you think the next biggest angle would be? N, because 13 is the next biggest side. Everybody see that? So 14 is the biggest side, so angle M is the biggest angle because it's opposite. Okay? 13 is the next biggest side, so what's the next biggest angle? The one that's opposite that. So angle what? N. And that has to be bigger than, what's the smallest side then? Or smallest angle, I'm sorry. L, because it's opposite angle. Oh, my angles and my L's kind of look the same. I'll try to make it look like an L. There we go. See what I just did? This goes from largest to smallest. Angle M is the biggest one. Angle N is the smallest, or the middle one. And angle L is the smallest one. How did I know that? Because of what sides they're opposite. The biggest angle is opposite the biggest side. Okay? The smallest angle is opposite the smallest side. And of course, the one in the middle is opposite the side that's in the middle. Make sense? Okay. Now, let's do that one that you drew earlier, and we can kind of do the reverse of that. All right. So hopefully you didn't erase it, but if you did, you could always draw it again. So again, this time they don't tell you the lengths of the sides. They tell you the angles. And I'm going to call this ABC. Okay, so now what I want to do, I want to put the sides in order from the biggest to the smallest. I could go the other way too, but I'm going to go largest to small. Okay, so from large to small. So what side is the largest side? And not just because it looks like it. I mean, you know 100%. What is it? B, because it's opposite the what? The biggest angle, okay? We're just kind of doing the inverse, right, of what we did before. It's actually the converse, but okay, the opposite of what we did before. So you look at the angles. This is the biggest angle, so look at the side that's opposite the biggest angle. That's B. So B has got to be the largest side. What about the middle one? Which one's the middle one? The middle side. It's A, right, because 60 is in between 20 and 100. All right, so A's got to be the second one. All right, and that has to be bigger than the smallest. 20 degrees is the smallest angle, so angle or side what? C is the smallest side. Everybody with me on that? It's not too hard, is it? The thingy at the top? Largest to smallest. Okay? Large to small. You could have gone smallest to largest, couldn't you? Okay, if I asked you to go smallest to largest, you would go what? C, A, and B. This one is actually called the longer side theorem. Longer side theorem. But you don't really have to remember the names of these theorems. Just know what they do. They kind of go together, don't they? Even though they got two different names. The greater angle theorem. You could say the greater side theorem if you wanted to. Yeah, they kind of do the same thing. Okay, if you just know, it just goes reverse, right? So whatever the largest side is, the angle opposite is the largest angle, and so on. Right here, if you know the largest angle, then the largest side is opposite the largest angle, right? So as long as you know that the largest side and the largest angle are opposite each other, the smallest side and the smallest angle are opposite each other, you basically got both of these theorems. It's pretty self-explanatory, I think. Would you agree? Yeah. All right. This is a really easy lesson, actually. We've got one more thing. Well, a couple more things. These are theorems, but they don't necessarily have a name to them. But one of them deals with a right triangle. So let's deal with a right triangle. here's something you may have already known before, but now we have a reason to back it up. Okay, so here we have a right triangle. So what side is the longest side on a right triangle? Why the hypotenuse? Why is this the longest? Because it's opposite of the biggest angle. On a right triangle, the 90 degrees is always going to be the biggest angle. Do you agree? Right? Because if you had an angle that was bigger than 90, then it would be obtuse. You can't have an obtuse angle and a right angle together in one triangle. Right? So on a right triangle, the right angle is always the largest angle. So that means the opposite side of the right angle always has to be the longest side. Do you agree with that? So what do we call the side that's opposite? We said it already. You guys said it earlier. It's the hypotenuse. So here's what the theorem says. Let me write that down. So the theorem says that the hypotenuse is the larger side in a right triangle. It's the largest. We can say largest. Okay, they say larger. I think I know why, but we'll just say it's the largest. So the hypotenuse is always the longest or the largest side. Always. Why? Because it's opposite the biggest angle, right? And so the side that's opposite the biggest angle is always going to be the biggest side. If it's a right triangle, it always has to be the hypotenuse. That makes sense, doesn't it? All right, and you probably knew that already. You probably knew the hypotenuse was always the longest side, but maybe you didn't really know why. Now you know why, okay? And then we got one more little thing. This is a real basic geometry thing that people learn. So let's do this. Put a different color. So what if I asked you the shortest distance from this point to this line segment right here? Or the line. I could have the line keep on going. Where is it? The shortest distance. Is it from there to there? Is it there, there, there? Tell me when. Is it just down, straight down? Let's do better than that. Let's not say straight down. Okay, it is an altitude. That's good. But it's what? It's not just straight down. It's not necessarily bisecting, because this could be a line. Right? This dot could be anywhere. It doesn't have to be in the middle. But it's got to be what? Give me the word. Perpendicular. Good. Okay, it's perpendicular, okay, to that. So the shortest distance from a point to a line is the perpendicular distance. And we've talked about that. We've done that. And like you said, it is an altitude. You're absolutely right. This is an altitude, but it's also the what? The shortest distance from here to here. Because if I would have drawn one to there, that one's definitely longer than that, isn't it? You agree with that? Okay. This is the shortest one. All right. So that's basically it. That's sections 5-3. That might be the easiest lesson we've done in a long time. Would you agree? I think we covered everything, didn't we? That's all I have in my notes. All right. So I gave you a lesson plan already, but I'll write it down. If Xavier's watching this, he can see what the homework is. Do you think he's sitting home watching this? I don't know. He might come in and say, "Yeah, Mr. Hamrick, I heard it say my name on the video." Tell you what, no, I'm not going to say it. I was going to offer him money to come in and say it, but you guys would contact him and say, "Oh, Mr. Hamrick said, what if you say that you saw the video, he'll give you $1." So it won't work anyway. Anyway, that's it. That's your homework. 1 to 18, section 5-3. Shouldn't be all that difficult. Everybody good? Yeah. Easy way to start off the new year, right? Yeah. Okay. Have that done for tomorrow.